So from between A to I, or like between like A, B, C, J, I, what is friction again?
Friction is just the force that's going to cause it to slow down.
Yeah.
Or sorry, not necessarily go as fast as it would have. So if this were frictionless, then the box would slide all the way to here, come back, and then come back up to the initial starting point. But I wanted it to stop before it got that far. So I have to add something in there in order to, as we'll talk about later, take some of the energy out of it.
Okay.
So that's why I added friction someplace. But it still speeds up from A onwards. It speeds up until it gets to D. But it's not as fast as it would have gone had there been no friction.
All right. Where is acceleration equal to 0?
Wherever velocity is also 0.
In which case, it never moved. And the problem is
Sorry,
a lie.
I'm wrong.
Is it like?
Where would you picture it's not changing its speed at all?
D through E.
Sorry?
D through E.
Yeah, on the flat part.
There's a slope over here, so it's going to be speeding up here. Here it's going to slow down and then speed up, and then it's going to start slowing down again. But this region right here, there's nothing to slow it down. There's no friction. There's nothing else. So in that section from D to E and G to H, acceleration is 0. And it includes D. It includes those letters because those are when the box is completely, or object is completely on that segment. So D to E, and then G to H. All right. What's happening if those are the only places where acceleration is 0? Then I've got 3 segments to pick, or to choose. So, Stephanie.
Would acceleration for J not be 0 if it ends there and stops moving?
All right. This is probably the biggest argument that students have tried to make with me on it. My contention is that J is that moment it stops. It's not the moment after, it's the moment that the box stops, the first moment it has stopped. The moment before, it was moving, and then it stopped. So I'm contending that there's still acceleration. It's not much acceleration, but there's still acceleration there. Now, if I extended the problem to the moment after it stopped, not the moment it does stop, then I buy the argument. All right, so what's happening from A up to not including D? All right, let's do it this way. From A to D, is it speeding up, slowing down, or?
Speeding up.
Speeding up. So it's going to have the same sign as the velocity, so that accounts for that, and that. And at point A, it is not 0. We'll just take that.
Positive?
Yeah. Well, it can't be negative because you can't go from negative to positive without going through 0. But it is positive because you put it there and it started to move. What about between E and G? Well, it is going on the right side, the right ramp.
Negative.
What?
Because when it's like going up, there's something like pushing it down, which is why it eventually goes up. Because F is where it is like it changes direction.
Okay. From a speeding up, slowing down point of view, on the way up, so on this section here, it's slowing down, so it's the opposite sign to velocity. In this section here, it's speeding up, so it's the same sign, so it's negative, negative. And at the turnaround point, negative, because there's still this net force acting down the ramp, as Moran was saying. And in the last segment,
be speeding up between F and G?
Yes, it is.
Okay.
The velocity is negative, acceleration is negative. And in the last segment, I suspect there's a debate going on. There's the intellectual side and the emotional side of the answer. Why? Alan?
Because it's the separation is going in the same, what do you say, sign as the velocity.
It should be the same sign as velocity?
Okay, so from H to I, wouldn't the acceleration be positive, but from I to J it's negative because it's stopping there? Or is it just negative to I? Makes no sense.
Tatiana?
No, is it positive all the way through since it's slowing down?
Yeah. You were halfway there to start with, Brom, and then you kept going farther away. In this last section here, from H to J, it's slowing down.
Yeah.
So the acceleration is opposite to the velocity. So my velocity is negative, so this is positive. And then we have at that point J, it's the same reason the net force is down the ramp. So in the first part from A to D, that net force is down the ramp in the positive direction. In this last part, that net force is still down the ramp, causing it to slow down. That net force doesn't change. And J is that moment it stops. So acceleration is tiny, not quite zero. But it is positive at the end. One thing I have not done yet, and hopefully I will remember, and if I forget, one of you is, it's okay to say, wait a second, weren't you going to be talking about graphs? I have not done the graphing of these. So in the last problem, would be considered the long problem. This is a test level, and then there's a final short answer problem that comes after it, where I say sketch the graph of position, velocity, and acceleration. And so that is I meant to do that for the ball problem, but that's something, save something for tomorrow. It's the cliffhanger. Any last moment questions? See you tomorrow.